Hello. Today we're going to talk about difference of squares and factoring. And you remember when we took two binomials and multiplied them, sometimes we had what we called the perfect square, which meant that we had a binomial answer when we were done multiplying. So the product was a binomial. In cases like those, they're special in that the way that they're spread out and simplified, combining those like terms, we have this binomial. So like this example where we have x plus 4 times x minus 4, we have x squared, and then we have 4x, and we have negative 4x, and then we have negative 16. Well, these two canceled each other out, and so then we're left with this binomial of x squared minus 16. Okay. Ones like this, I have 9x squared minus 3x plus 3x minus 1. Again, these canceled out, and I get 9x squared minus 1. So because those middle terms canceled out, that means that these are what we call difference of squares. We called it difference of squares because the last term is a negative, which becomes a subtraction. And again, a negative that becomes a subtraction. So when we're doing these are called perfect squares in binomials. We know that we have perfect squares in our numbers because we can take and find our perfect squares. And you'll notice in your notes that I gave you some perfect squares that go all the way down to 15 squared. And if you want, you can always go beyond that, but 15 squared is as high as the list that I gave you in your notes. And we know that 2 times 2 is 4, 11 times 11 is 121, 12 times 12 is 144, and so on down. Okay? We can take that information and we can now factor out these perfect squares. So I have my example, a squared minus b squared is equal to a minus b times a plus b. It's important to notice that the operation in both of the binomials is the opposite of each other. So when I am looking at this example here, I have 9x squared minus 4. I notice that 9 is a perfect square, and I notice that 2 or 4 is a perfect square. The square root of 9 is 3, and the square root of 4 is 2, and the square root of x squared is x. So I'm going to have 3x and 2, and 3x and 2. And remember, because it's a negative 4, one is going to be positive and one is going to be negative, and it really doesn't matter which one is which. Okay, so let's take a look at the next example. I have s squared plus 9. S squared is s times s. And 9 square root of 9 is 3. It's positive. So in cases like this, we need to be very careful and see if we can make this work. Because before this was negative, and we've got a positive and a negative. This time we have positive, and it either has to be both negative or both positive, right? So let's take a look at that. If I were to factor this, or go ahead and multiply this out and find the product of this setup, let's see what we get. If I go ahead and FOIL these, I get s squared, and if I use the minus, I get minus 3s, which we know that if I do that, I'm going to get minus 6s plus 9. It does not cancel out, does it? And if I look at this one, I have, if it was all pluses, then I get s squared plus 3s, which again is plus 6s. It does not cancel out, and then plus 9. So this is a prime example. This is an example of prime. Then we have this next one, which is 225x to the 4th power. 225 is a perfect square. It is a perfect square of 15. And then they each have x squared. And this would be 5 times x and 5x. One is positive, one is negative. So I get 15x squared plus 5x, 15x squared minus 5x. And because one's positive and one is negative, the center will cancel out, and the all we're left with is this. Okay? If you have any questions, please make sure you see your teacher. If you get stuck, especially in ones like this, just know that if I can't simplify this down into 2 binomials, it's prime. There is no greatest common factor for it. Okay?